Let's do this. Good morning, everyone. It's Friday. We made it. Welcome. This is the Security Area Advisory Group. My name is Roman Genilio. I am one of the security ADs, and sitting next to me is
Paul Vargas, who is the other security AD.
Let's get started. All of the slides are in the data tracker if you want to follow along there. And we also have kind of meeting minutes. So if you want to help collaboratively edit those, that's a possibility as well. On the screen is the Notewell. Just a reminder, you've seen this every meeting you have attended. We have various kind of policies and procedures kind of in place. Please make yourself aware of them. The key thing we, of course, want to point out here, we are in a professional kind of setting. Please focus on our code of conduct and remember to be respectful to your peers. Let's talk about the technical work. Let's not talk about the individuals bringing the technical work forward. We probably have as many participants remote as we have in this very small room here. I'm not sure why we got sized the way we did, so it will be kind of intimate. What we have up are a few tips about how to make the experience most productive. If you are in the room, please scan the QR code to bring up the Meet Echo Lite client. And please have your kind of mask on. If you'd like to join the queue, please use the queuing tool. When you are not speaking, please turn off the microphone.
And just a note on the mask wearing and sipping a drink. You can remove your mask if you're sipping a drink, but as soon as you're done sipping a drink, please put on your mask. Thank you.
We have, this is the agenda we previously had published. We're going to go through the administrative and summaries of the area. We are going to have Margaret Cullen give us a talk on significant adoption of a couple of key IETF technologies. Then we're going to talk about formal verification. This is a topic that has popped up in a couple of other places. And then Justin Richard is going to talk to us about HTTP message signatures, which is, I believe, in working group last call in HTTP BIS. Pausing there for any agenda bashing. Not hearing any. Let's press forward. Wanted to call out a couple of things. Participating in the security area means a lot of different things. We welcome kind of hearing more from interested participants about how you would like to participate. There, of course, is sitting on this side of the room. If you are interested in being a chair, please let us know. Another great way to get involved in kind of the real business of how the working groups do things is be a document shepherd. This gives you a lot of insight into how to do document reviews and IETF process, and it is a tremendous help to the working group authors, and to Paul and me. We're going to talk about this later. There are all sorts of errata in the security area that we need to do a little bit better job at closing. This is another way to learn about how we do maintenance on IETF protocols that we publish, some in active working groups, some not so much, and that's certainly a place where we need a lot of help. And then, of course, participating is, if you can't make it in person, the virtual experience. These are, virtual participants are first order participants kind of as well. So please join, especially in BOFs, to help us understand what work we want to bring into the IETF. So I will say you're going to see something a little bit different. Paul introduced an innovation here that maybe we don't need to run through all the different working groups. So we are going to largely manage the queue from now on, by exception if folks want to come forward and talk about things. So first order of things, we've had some changes in working groups and some talk of new work since we last met at IETF 14. We had a virtual BOF between 14 and 15, originally titled JSON Web Proofs. And then if you jump to the next category, there was consensus out of the both in-person, we had an in-person BOF and then we had a virtual BOF. Coming out of that virtual BOF, we had consensus to move forward with chartering to reopen the Jose working group, and that is in flight. That is in flight now. It's going to be looked at the ISG in early December. Earlier this week, we also had the RADX BOF, which is to reopen, is to do more radius work, and then we also had the SAT-P BOF. And meeting for the first time as a working group is SCIT. A thing to kind of call out is what's at the bottom. the IETF overall introduced a new way to do BOFs, or brought back, I'm told, for folks that have participated a long time, this notion of virtual interim BOFs. That is, you don't have to wait to the face-to-face meeting to have a BOF. We've now used that successfully 3 times. So Tigris, which is in the app area with security considerations, we used it to move Skit forward, and we also used it to move forward to what's getting chartered now. We'll see on the community feedback and Jose. And so kind of bottom line, it looks like it's cutting out at least a half meeting cycle for work to get new work kind of chartered. And it looks like a successful approach, and I see us continuing to use that. So this is the compression of what normally would be 20 slides. Thank you, kind of Paul. A lot of working groups met in this last week. I believe almost all of them sent a summary to the SAG list. That's where all the details are. We invite any working group chairs or participants to come up to the mic and now tell us about hot topics or anything they think SAG should know about those previous meetings this week. And as you,
I was going to say, this could be positive news as well if you want to be proud and come to the mic.
And also to talk about kind of process here, the next question is always, do you want to come up to the mic to talk about non-sec areas? So flipping back and forth, did something happen that you think is security relevant across the IETF this week that you want to share with us at SAG? All right, well, perfect. I'm sure we're going to read everything that's on the mailing list. Okay, so pulling us to some of the administrative updates that the ADs would like to share with you. First, we want to highlight that one of the ways in which working groups are successful, it really is because of the leadership of the chairs facilitating the technical work. So to highlight some changes, we want to thank Mohit and Richard for chairing Sec Dispatch. They have rotated out. If you're on the Sec Dispatch kind of mailing list, one of the things that we did is really rethought what to do with standing working groups. So with working groups that don't have an end to their work, like Sec Dispatch, when a working group chair signs up, the exit plan is, unless we say, let's rethink this, or they tell us they're out, they will be working group chairs kind of indefinitely. We wanted to set up a rotation process. And so we've roughly created a policy in Sec Dispatch that it's about a 4-year term, unless we think there's an issue or they would like to step down. And so Richard has been in that role for 4.5 years and really launched the process for us. Rifat is stepping in for him. Kathleen is 3 years into the term. This coming summer at IETF 17, she is going to rotate out, and we would expect that the ADs kind of at the time, Paul and whoever is the AD at the time, will kind of make that selection. So this is kind of this idea of with standing working groups, we should rethink what happens. And then we spun up the new Skit working group, and so kind of thanks to John and Hannes for stepping in to lead us. If you are interested in working group chairing, we regularly put out a call to SAG, and we will kind of continue to do that. You don't, in fact, need to wait for the call. If you are interested, drop us kind of a note, and when there are chairing opportunities, we consider that list. We didn't create any non-working group mailing lists since we last met. Our queue for AD sponsor documents is getting kind of a little bit deeper. So this is real time as of at least Sec Dispatch yesterday. Where we added the draft Leggett SPCAC for AD sponsorship. And then we have not yet closed the action item for Sec Dispatch 114 to land draft Eastlake FNV, but we are going to work on it. Are there any questions about the AD sponsor drafts we are holding? We especially point them out here because for folks a little less familiar with the process, AD sponsorship means it's not going through a working group. So the review process is the formal IETF last call and whatever we as ADs trigger. So these documents are here primarily so you have visibility as SAG, and we would beg for your reviews on those documents to make sure that they leave the IETF and is the best quality as we can get them. So I talked about this a little bit, about errata processing. We need a little bit of help. The backlog is growing a little bit each and every time. The heavy hitters are the working groups you see here below. we would ask that those working groups help us burn down that backlog. We nudge again. One unique thing that we did that isn't kind of part of this structural update that you've seen a number of times is we convened what we call the PQC next steps or additional next steps side meeting on Monday. And the thinking there was we saw a tremendous amount of energy on the PQC mailing list that we spun up a little bit before IETF 14. Additionally, we had a SEC dispatch result in 114 to pick up what we considered a transition support document around PQC. And after kind of thinking about the energy on the list and what we wanted to do with that document, we shopped around a charter to what we're calling the PQC Transition Support Working Group. So this is a working group that is not intended to change existing protocols. It is a forum in which to discuss design and transition choices that are relevant across the SEC working groups and probably across kind of the IETF. And all it's permitted to do is that facilitation, that discussion, and when discussion really is probably reusable or it makes sense for it to be durable for archival purposes, that working group would have the ability to publish informational documents. It appeared we had consensus for that from the mailing list. It appeared there was really strong support for that from the side meeting. So at this point, we are likely to proceed with chartering. The big blocker is, as everything in the IETF, one of the most important things is choosing a name, which we have not, and we got to dial in the deliverable. So we welcome kind of additional kind of feedback and polish. Please put that on the PQC list. There is a very long thread about what's there. Other things we talked about were.
I'm having a problem.
Oh, yeah, sure. Please, Paul.
You just said something that you didn't say in the BOF that I'm, or the side meeting that I'm a little bit concerned. You said informational documents, whereas sometimes some of the discussion was about best current practices.
Oh, sorry. I was being imprecise. What I meant to say is we are not doing PS.
Great.
We're not doing standard.
Okay.
Right.
Great. Thank you.
Yeah. And we're not making changes to protocols. Yeah, please check the charter text. I believe we do say that, but if not, let's polish. We asked two other questions, and this is a little bit of, we see energy and we've been coming back to you in SAG, double checking where we want to be as a community. We were trying to check out where do we think there is a bunch of working groups that are active doing PQC kinds of things. We wanted to check, are there technologies that were previously in the IETF or IETF adjacent where we think work needs to happen, but there is not a natural place to do that work to perhaps kind of figure out how we should discuss agility in those working groups. So from the side meeting, we heard SSH, we heard Kerberos, and we heard XML signature. If you think there are more, please kind of let us know. If you go to that GitHub site that we're going to migrate to the IETF kind of wiki, there's kind of a place where we're capturing that list. And then the third question we asked was, we often rely in the IETF on directorates to help us do document reviews for specialized things. So a specialized, we have the security director, but we also have niche things like Yang. So if you have a Yang document, you can go to the Yang doctors to help you specifically do that. The question was asked, do we think we need something for just post-quantum cryptography reviews? So a PQC directorate. The feedback from the side meeting was no, we're not ready, and now is not the time to do that. If you want kind of more information, there are some references there. Okay, other highlights. We try to, us in the security directorate, try to keep a running list of things that we are likely to discuss on at the ISG telechat. And this is a little bit of a service to the rest of the IETF of, hey, write good security considerations, but here's another list to double check, because even after having all the guidance we have about writing security considerations, Paul and I often find common themes. And so that URL up there is what is the common themes we see the sector review putting in kind of feedback, hey, you need to think a little bit more about that, or issues that Paul and I commonly discuss on. This is kind of a running list. This is something that we started kind of a number of years ago. I just highlight that if you have feedback for other things perhaps you are doing, if you are reviewing documents kind of in the working groups. One thing we just added to that list, because we are seeing it in a number of recent kind of telechats, is that that documents are coming to the telechat review, and they are saying we are fielding this in a limited domain. And beyond that, there isn't a lot of specification about what are the security properties of that domain, how are you bounding that domain, and how are you controlling things that are in there. And so that's an example of a flavor of kind of common themes that we would put on that. If you want to get a sense for where we are with your documents, those are the pointers to the queue. There is fairly detailed kind of insight, when we take the document for ISG processing, where we are kind of with that process and how far we have advanced it. Just a reminder, we have a SEC area kind of wiki. The IETF is migrating its wiki technology from Track to Wiki.js. So that URL is where we are right now. I would expect in a couple of weeks that URL will be something different. After that migration occurs, we'll make sure we send a pointer around. And we are in that time of year in the IETF where we have spun up the NOMCOM to choose the new leadership for the IETF. As every year, there are kind of candidates for the ISG, so with the security AD, all the rest of the ADs, for the IAB and kind of the other key leadership positions. The NOMCOM really relies on the community for feedback on how to make their choices. So please, if you want to have a say in how leadership is chosen at the IETF, go to that URL and provide feedback on those candidates. In close, we can't emphasize enough how helpful the Security Directorate is to the IETF to help the working groups polish the documents, find issues, and really get us to the point where when we go to RFC, the documents are as good as they can be and with as well-rounded of any kind of an assessment. So thank you to the Security Directorate. They made kind of this possible, and these are all the folks that helped us review documents across all of the working groups for everything that went to IETF last call since we got together. And also a big shout out to Tiro, who is our secretary for the sector reviews, and literally every week to every kind of 2 weeks is making the assignments of those documents and what needs to be reviewed. If you are interested in participating in Security Directorate, please email Paul and me, and we can have a conversation. All right, so I will pause there. Anyone have any comments, kind of questions for the administrative thing before we get to the meat of some of our talks? I'm just checking the queue here. Okay, the queue is clear. So in that case, we're going to switch over to Margaret, who's going to tell us about EduRoam and some adoption of IETF technology at scale as an implementation report. So Margaret, if you want to hop on, I'm going to switch the slides for you.
Okay. I think I'm here. Can everybody hear me?
We sure can. The floor is yours.
So I'm going to talk about an implementation report on the use of EAP and Radius for US EduRoam. EduRoam is a service that's been around for a long time, 20 plus years. US EduRoam has been around for a long time. We did a new implementation of US EduRoam in AWS, and it was new to us to operate and deploy this service. And so we're going to offer some observations we had about those technologies while we were doing that. So next slide. We worked with Internet2, who operates the US EduRoam service, to implement and deploy a new Amazon Web Services-based US EduRoam infrastructure. It went live in November of 2021. So we've been operating it, monitoring, and maintaining it for about a year. It's free radius based, it's geographically redundant, and then within each geographic region, it is load balanced. And I will talk more about that. The goal of this presentation is to share our experiences implementing and operating this service. And much of this presentation focuses on need for improvement, but I want to emphasize that a lot of those things are small things. And actually, the overall experience has been very positive and highly successful. So it's up and running, and it's stable, and it's working well. But there are a lot of small things that we think either could be modernized or added that would make it a lot easier to deal with. So next slide. So this is a little outline of the talk. The first thing I'm going to do is a quick review of what EduRoam is, just because there may be people in the room who don't know what I'm talking about at all, and try to bring them up to speed. And then we'll do an overview of the US EduRoam deployment, including how we deployed the infrastructure and some facts and figures about it. Then talk about how requests are routed in EduRoam and some things about how that works that have been a struggle. Some security challenges that we've run into, and also some operational challenges that we've run into. So next slide. EduRoam is a widely used international roaming service for higher education and research. As I said, it's Josh sitting in the front row could probably tell us exactly how long it's been out, because I believe he did the first deployment of it, but it's been out for a long time, decades. It allows students and staff from education or research institutions to access the internet at remote EduRoam service locations. So basically, there's a common SSID, EduRoam, and students walk around having free, seamless access to the internet using the EduRoam SSID, just like you could walk around your house. If you had multiple access points in your house and use the same SSID, and never have to change your configuration or go to a captive portal or do anything to stay on the internet. Sometimes it could provide more privileges or better performance than a public guest access, but even when it doesn't, the fact that it's free and seamless is in itself a better service. There's a home institution, which is the identity provider for the user. So a student would have a home institution at the university they attend, and that university will have verified the user's identity and provided credentials to them to use EduRoam. Then that student can go to other locations, EduRoam service locations, relying parties, right, and visit those locations and get access to the internet. With that location proxying an authentication request into the central infrastructure, which goes back to the home institution and authenticates the user. Millions of students from thousands of home institutions access EduRoam at tens of thousands of service locations throughout the world. It's a very large-scale service. And if you want to hear more about EduRoam itself, you can go to that URL there, or talk to Klaus, because I think he works at that organization and knows everything about the central EduRoam service. But if you go to the next slide, I have a little picture of how it works here. If you look on the right-hand side, well, let's start with, there's a user, and the user is John at institution.home, okay? He once was at his home over on the left, and he got identified there, got issued a student ID, got issued credentials. He then traveled to another institution, institution.visit, where he wanted to get on the network. So he logs into the network using his home credentials, and the visited network goes up to the EduRoam top-level radius server, over to his home IDP. He gets authenticated, the answer comes back, and he ends up on the network. I just somehow lost my slides, which is going to make it interesting when I tell you to switch to the next slide.
Yes, we're going to rectify that. I lost the slides here. Stand by.
Okay, so you can go forward to that picture and then, oops, nope, back. Okay, next. There's a bunch of underlying technologies. I could have made a much longer list of RFCs here, but these are the core ones. radius, EAP, how you run, EAP over radius, and then the various methods that you can use for EAP authentication, and then also the 802.11 and 802.1x specs from the IEEE are the core technologies that are used in Eduroam. Next slide. There's a proxy hierarchy in Eduroam that lets it run all over the world. And the way that this proxy hierarchy works is that the individual Eduroam institutions have their own radius servers. Could be the same radius servers that they use to have people log in at other SSIDs, or could be dedicated to Eduroam. That's totally up to them. Their local servers are configured to send any, well, at least when you're on the Eduroam SSID, to send requests for any realms that aren't local to them up to the national servers at which they are registered. And the national servers are set up so that they send any realms that aren't in their nation up to the top level servers in Europe and Asia. And that is basically how Eduroam requests are routed throughout the world. Next slide. So now we're going to talk about the US Eduroam deployment. If on the previous slide I had thought to mention it, I could have said one of those national servers is the US national server. And that server is run, or that proxy, the US national proxy, is run by Internet2 in common. And we work with them to run that service. The US Eduroam service has greater than 1,000 home institutions, or IDPs, greater than 3,000 service access points, or RPs, and somewhere in the area of 2 million eligible students and staff to use the service. We can't say how many people are actually using it because some people only use it locally. We can only see from running the national proxy the people who roam. So we don't know exactly how many people out of those eligible students are using it. There's a URL here if you want to see more about US Eduroam, but I don't want to go into a huge amount of, it's not an Eduroam tutorial. So that's basically US Eduroam. And next slide. The way we're currently deploying the architecture, as I said, it's in Amazon Web Services. This picture has a lot of details on it, only some of which really matter. First off, this is half of our deployment. This is the East Coast deployment. There's a mirror image on the West Coast. We have a server in the Internet2 data center that the traffic comes into at an Internet2 address. There's a sort of traffic engineering activity that happens there where the software, the traffic is natted and sent over a VPN tunnel to AWS, where we run the actual a router to be the endpoint of the VPN, and then the actual radius proxies. This picture shows a primary and a backup because it hasn't been updated yet, but actually at this point we're load sharing between the two servers running on each coast. And as I said, it's then duplicated. So we have 4 servers running, all acting as a single cluster of servers as far as the Eduroam service is concerned. Next slide. I thought it'd be interesting to give some facts and figures of what we've been doing. Up to 100,000 radius messages are received per minute at peak times. We see somewhere, greater than 12,000 unique authentication requests coming through per minute. An authentication request involves several packet exchanges, so it's there's not any sort of one-to-one between messages and authentication requests that complete. About 2/3, 65% of the authentication requests that are made in the US get an access accept, and about 35 get an access reject. This is of authentication requests that complete without some sort of internal error. About 18% of the requests we receive are rejected or discarded by our proxy, and some of the biggest reasons that happens are Request looping, where basically proxy looping, where basically we're receiving back a request that we've already touched. Missing or malformed username or realm. Unknown client, just isn't registered with us or isn't known to us. An invalid authenticator or a malformed message. Those are the errors that we most often see that cause us to reject or discard an incoming request. Next slide. The EAT method distribution, I thought this was interesting when I first saw it. We see about 75% PEEP, 15% EAT TLS, and 12% EAT TTLS. This is from a report in Q1 of 2022. I haven't gone through and tried to look at it again to see if we have any trends, but that's where we were at that time. Next slide. One of the things that's tricky about EduRoam is the way that we handle the request routing. There are two sets of top-level EduRoam operators, one in Europe and one in Asia. And there's a national roaming operator in each country who's responsible for enrolling the EduRoam institutions in that country and also proxying between them. So only requests that go from one country to another go through those top-level EduRoam servers. Within a country, they go through the national EduRoam server, and then locally within an institution, they would just go to the institution server. Each of the NROs provides a JSON formatted list of their enrolled institutions to their top level provider. For example, US EduRoam provides a list to JAONT in Europe. If that sounds a lot like a 1980s internet host file, that would be because it is a lot like a 1980s internet host file. Okay, we say, we know these hosts. And basically the whole thing is being routed by files that are being exchanged once a day, saying, all these people are under me, please send their traffic to me. So if an institution radius server receives a non-local request, it goes to the NRO radius proxy. If the NRO radius proxy does not have a matching realm registered, it forwards it up to a top-level server. The way our servers work, if the country code is included in the realm name, we forward the request accordingly. We send Asian countries to Asia and European countries to Europe. But what we do if the country code is not in Europe or Asia, or if there's no country code, it's just example.com, is that we do some round robin between the top level servers. There's multiple servers in each of Europe and Asia. And if the top level operator doesn't have a registration request of their own, they need to forward it over to the other top level operator. And so basically things can be forwarded several times. This isn't a completely flat structure. So if you look at the next slide, an inefficient, this is like the most inefficient you could be in a real example, is that a user from example.com, which happens to be a Canadian institution in my example, visits a US EduRoam service location and attempts to join EduRoam. The service location, radius server, so that's the first radius server that touches it, determines that example.com is not in the US, is not local to that institution, and it forwards the request to one of the US EduRoam proxies. The US EduRoam proxy, that's the second radius server to touch the packet, determines that example.com is not a realm registered in the US, finds no country code, and forwards the request to an Asian top-level radius proxy, just by round robin. The Asian proxy, that's the third proxy to touch this packet, this request, this message, determines that the IDP realm, example.com, is not registered in Asia, so it forwards the request to a European top-level server. The European top-level server determines that example.com is registered by Canada, who I am presuming registers with Europe, but I could be wrong, and forwards that request to Canada's radius proxy. The Canadian proxy, that being the fifth proxy, forwards the request to one of example.com's radius servers. and that is the 6th radius server to actually see this request. So it can go through 6 proxy hops through 6 servers, 5 hops, before it gets to the ultimate destination. And that could be a normal, successful authentication exchange. So the next slide.
I'll forward your slides, Margaret. Can you really retry your video? We just lost your video feed. Maybe hop off and hop back on. There you are. Perfect. Thank you.
So, you could say, well, six hops or 5 hops through 6 servers is not that much, but it's actually the case that a successful edge roam authentication also requires several request response exchanges. I've seen them from 3 to 7, although I don't think we get 3 using the methods I just listed. And it depends on the EAT method and the size of the credentials and a few other things. But we see several usually message exchanges. So request response, like access request, access challenge, access request, access challenge, request response exchanges before we get to an answer in a typical radius request. So we're seeing a multiplicative value there, right? We're going through 6 hops. We've got, let's say, 5 messages. And every time a message goes through a hop, there's a cryptographic message authentication performed. So more efficient routing than this would be highly desirable. A lot of times people aren't waiting to get on the network, but if you are waiting to get on the network, the delay can be quite noticeable from using radius. But it's hard to know how to get more efficient routing because we don't do any sort of dynamic routing, and we don't even have the equivalent of ICMP redirects. So even if Asia knew that example.com should have gone to Europe, there's no way for them to tell us. And there's no standard mechanism for loop detection or prevention. So this complexity sometimes does seem to result in looping, which is, it varies a little bit, but often is the highest rate of errors we're getting that's causing us to discard packets. So next slide. The other thing we found that was difficult for us is that there are very few testing or debugging tools for this type of multi-level proxy fabric. There's when a remote EPA radius request is dropped or rejected, it can be very difficult to figure out why it didn't work, or even figure out what server dropped it or rejected it. A lot of things are silently dropped. And access reject messages don't typically contain a useful error code, even if you do get an access reject message back. So you're often trying to figure out what went wrong. There's a status server request in Radius, but that only goes 1 hop. You can only send it to that first server that you talk to that you have a shared secret with, so you can query the health of that server, of that proxy. There's no way to query the health of the more remote proxy that's multiple hops away from you. So there's no ping that would go across multiple hops. And then also there's no way to trace the path that a request would take to see if the path is valid or looping or what. So there's no like trace route like functionality that we can use to debug these problems, which ends up with people literally calling each other on the phone and asking them to check their logs. That's how you debug a multi-hop radius routing problem today. So next slide. There are also some security challenges. Eduroam is a security service, and it's based on Radius, and Radius is good and works well. but its message protection is pretty antiquated by today's standards, and this comes up sometimes when you talk to people about EDGEROME. It consists of pairwise shared secrets and an MD5 hash for message protection. And the shared secrets are often typed by administrators into a UI or a plain text file. There's no consistently enforced minimal length for those keys, nor is there any requirement for cryptographic generation of those shared secrets. And there's no algorithm agility for the MD5 hash. And I think this came up in the BOF on Monday, although when I first started working on these slides and talking to you guys, the BOF wasn't even a glimmer in Alan's eye, as far as I know. So next slide. There's also a trade-off that our subscribing institutions run into between privacy and secondary credentials. Now, there's no reason in the world that there's an inherent trade-off between privacy and secondary credentials, but there is in EAP over radius. And the reason it has to do more with what's available for methods than it does with any technological reason why it has to be this way. User privacy is absolutely essential in EDGEROME because the risk is exposing the physical location of an end user, right? You're not going to expose the fact that they went to this website. You're going to expose the fact that they're in a particular room at this time. So if some of the people in the SAAG room are on EDGEROME, their home institution can actually tell where they are physically located.
So, Margaret, you can't see the signaling in the room. I was raising my hand, as were a couple of others in the room that were on that wireless network.
So, but you wouldn't want possible attackers to be able to figure that out. Possibly not even the IT people at your home institution. But but there are issues with that, which I'll talk about. And then the other desirable thing that you want in EDGEROME is the use of secondary credentials. So such as certificates or maybe derived credentials. I'm not talking about multi-factor. You might want that too, but that's a whole nother question that maybe I should have put on these slides, but I did not. But secondary credentials such as certificates can be valuable to allow passwordless authentication or to protect primary credentials from being used in an environment where they might be exposed out on the internet. So your user may have primary credentials they use for logging into university services, but you don't want them to use that same credential to use EDGEROME because they're going to go out and use that credential in Starbucks or whatever. So people want both of those things, but there's a trade-off. PEEP and TTLS are pretty good on the privacy side. As long as you configure it right, you can use an anonymous username in the outer method so that the username portion is only ever transmitted over an encrypted tunnel. So that's pretty good. You can't necessarily tell where a person is. EAP-TLS is pretty good for secondary credentials, but the username is exposed in plain text in the unencrypted client certificate. So there's a couple ways you could go to try to fix this. One is that you could support TLS 1.3 and EAP-TLS so that the certificate would be encrypted, or have wider use of RADSEC to encrypt the whole session. And those would meet both requirements, but those are also both PKI solutions. And there's some people who don't want PKI solutions, which is why we see PEEP and TTLS combined being a much larger deployment, at least in the US, than EAP-TLS. But I don't know of any combination of currently available methods that would give you both of those things in a non-PKI solution. So that's where we are. We don't actually have any of those things fully today, like RADSEC's informational and EAP-TLS 1.3 I think there's been some talk about that, but it's not in implementations. And I don't even think we have a draft that would offer a non-PKI solution that would let you do both of these things at once. So next slide. We ran into some operational challenges as well. I talked about looping. It's the most frequent cause of just dropped requests. There's no way to, there's so many things you can't say in Radius, right? There's no way to send error messages. So we just have to drop the request because there's not really a way to go back and say you were looping. Also because you don't want the response to end up looping as well. And we have a way that we notice looping with the vendor attribute. Other people have other ways of noticing looping, usually requiring a vendor specific attribute. But there's no standard method for detecting looping or letting another server know that anything's looping. Also, separate issue, many clients will retry a failed connection request immediately with the same credentials. So they get back an access reject and they just try again. We had one example that involved 37,000 requests every 5 minutes until the manual intervention at the service location. They had a comma edu at the end of their realm instead of a dot edu, and their supplicant just tried to authenticate as fast as it could 37,000 times every 5 minutes until somebody went and blocked that particular user. I don't know why that's the case, and would like to figure out if there's something better that we could say that would get them to back off or stop. We get a lot of people who have long expired or obsolete credentials still configured on their devices. Like you might say, why 35% error rate? Those aren't proxying errors. Those are the IDP saying, no, those credentials are not valid. And most of the time that's because they're obsolete or expired. There's no way to signal for the IDP to signal to the device that those credentials need to be invalidated. Supplicants will try to use obviously bogus credentials. Realms with comma edu in them, things with no realm, things with white space or special characters in the username or the realm, missing realms, expired certs. Like supplicants aren't doing anything to try to decide if this is a reasonable request before sending it, which is frustrating because we get a lot of those as well. That I think was third down on the list of reasons why we have to throw away requests. And then the last one I have, and I've tried to research this to some extent, is that we receive many requests per second with realms of the form WLAN.MNC 3 numbers, .MCC 3 numbers, .3GPPnetwork.org. And as far as I can tell, we are somehow being mistaken for a 3GPP carrier network, but I can't figure out how to make it stop. So those are my random, leftover operational challenges that we see pretty much every day. So the next slide. There is some ongoing progress because since I originally offered to make this presentation in the spring, and I didn't even, and I had COVID during the last meeting, so that wouldn't have worked out at all. Some work has been proposed in the IETF, in some cases by us, because we've been talking about these issues and said, well, we could write a draft that would address some of the issues that we've encountered. Some of them are in the RAD-Extra BOF and the RAD-X rechartering effort. And then also Josh talked about EAP-DI and EMU. But some of the things that we're struggling with aren't actually being worked on anywhere. I would be interested at least in trying to contribute if somebody had a good way to solve some of those problems. Next slide. So these are the three people who talked about this presentation as it was under development. It's just our own observations and opinions. It doesn't represent the views of Internet2, certainly not of edgerome.org, who none of us work for, or any other company or organization. So there you have it. Those are thoughts on deploying EAP and Radius in a great big multi-level proxy application. So I think the next slide asks if there's any questions.
So thank you, Margaret. This is, as the BOF chair for the Red Extra group, this is extremely helpful, and you've basically done most of my homework on making various evaluations on whether it's a good idea to open this group or not. So thank you very much. Very interesting talk about existing technology and how it evolves and the problems. And so are there any questions, comments from people in the room?
Yeah, hi, Jan-Fred, EduRoam enthusiast and national roaming operator in Germany. Margaret, you talked about load balancing and failover mechanisms. In Germany, we had tried that once, but failed spectacularly because, of course, there are the two layers, radius and EAP. And if you don't recognize the EAP layer and you just distribute the radius, then you end up with failed authentication requests. How do you deal with that?
We are just load balancing based on IP address. So a particular, SP will, a particular SP, all their requests will go to the same internal server, which does mean we don't get perfect load balancing because some are busier than others. And if we're unlucky that day, we may get 2/3 of the traffic going to one and 1/3 of the traffic going to the other until some event occurs where both those machines are constantly monitored and restarted if something goes wrong with them. So, and sometimes they're rebooted for operational reasons, updates, stuff like that. So we don't get perfect load balancing, but we do it all on IP address rather than trying to do anything out of the radius or EAP because it's not, or even the ports, because we end up with, if we do that, we end up with traffic. I mentioned for people who aren't aware of what he's talking about, that there are several exchanges for each authentication. Those exchanges have to go through the same proxy because the proxy has state. So basically, we're doing just a much sort of coarser grained load balancing in order to avoid those problems.
Okay, did you look to do something with a username, for example, or the MAC address of the device, the calling station ID?
We have mentioned that in meetings, but we haven't needed to do that in order to get the redundancy that we need, or we were having some trouble with the entire portion of, especially on the East Coast, because more people use the East Coast server than the West Coast server for some reason. Having all of the stuff people sent to the East Coast IP address going to one AWS server we were running into non-protocol related problems, load problems. And so what we're doing now is enough to actually make the load low enough that we're not running into those problems. So we haven't had to do sophisticated.
Mark Donnelly of Payload Security here. We've also tried to avoid deep packet inspection for fear of performance problems.
Okay.
And so we, as Margaret said, we've determined that the source IP address is sufficient for us.
Okay, thank you very much.
Leaf, I think you said you were having some issues putting yourself in the queue.
I was trying to get on the, now I realized I dropped my mask somewhere, but anyway. Can I just go on the mic queue anyway? I'll drink and speak at the same time. All right. Whatever. I was gonna come. Oh, thanks. Lifesaver. Thank you. Yeah. So what I was going to come up here and say is that if we're looking at sort of things where the IETF could actually help in this space, right? There's another kind of even more pressing problem, and that's kind of the lack of onboarding and provisioning mechanisms for endpoints at large-scale deployments of Wi-Fi. And Elliot actually brought this up in a couple of places, including in SCIM of all places, because he kind of has this idea of using SCIM as an onboarding protocol for endpoints, which might seem a little bit odd, but I mean, there are kind of reasons for that he's talked about. But in any case, I mean, today, if you're deploying Wi-Fi at scale, and you're not doing mobile management, right? Then doing something like cross-org, cross-domain, cross-everything, right? It is a challenge because platforms do not align here. They don't share like common APIs, common models, even anywhere not remotely common capabilities. And that's a problem for large-scale rollout.
Mm-hmm. Yeah, that's, I think, the biggest pain point reported by our customers. I guess I didn't mention it because I, don't play product managers on TV or anything, but if you talk to our subscribers, that's the biggest problem that they have, is how to onboard the users to Eduroam. If we could come up with a solution that would actually make that easy, that would help with deployment. It might help Radius Neat be used in other large-scale deployments where that might be an even bigger issue. I mentioned on a slide, but didn't say that in the U.S. at least, we're moving to K-12 and libraries, museums, etc. Not research institution libraries, but just regular libraries. And that also has challenges in that area because those places have even less IT support, help desk support, et cetera, than a small university.
Paul Hoffman playing tourist here. Margaret, you just said something that scares the crap out of me. As somebody who's a good friend of somebody who works in the public library in Santa Cruz, who already has plenty of issues because the public library is basically the internet connection point for the large homeless population that we have. Doing onboarding as they do now is already rough.
Yeah.
I haven't been in SAAG in a long time, but boy, would I encourage people who are thinking, where are hard problems that touch end users as compared to the network, to work on this. If this comes to them, there will be an expectation because they already do free internet service through local internet service provider and stuff. Helping them out would be like a huge thing. I mean, like I hear her complain to me reasonably often that, she spends a long time filling out forms for people who just need to get on the internet for 10 minutes to see whether they have a place to sleep that night. So please, yes, onboarding.
Well, this came up a lot with children out of school for COVID, at least in the US as well, that they would, end up outside like Taco Bell or something, trying to get on the internet. And so there's a big desire to get all those school children on Eduroam and have a lot of Eduroam service points so that if something like that happened again, they'd have somewhere to go to get free internet access.
Okay, so there's no more further questions. So thank you very much, Margaret. And we'll go on to our next item, which I believe is the HTTP, no? Oh, the formal proof item. Yeah.
So we're switching to the next topic, which we hope will be a little more, will be interactive because we want to get feedback from the group. So the tee up is that we in the security area have relied on outside help to do formal verification of security properties across a number of working groups, frankly, to a lot of great success. So if we think about the Tron workshop that helped us do formal verification, that helped us bring academics in that are doing formal verification for TLS 1.3. If we think about in Lake for the ad hoc protocol, if we think about IP components of IPsec, if we think about MLS, I am sure in OAuth and GNAP. So I'm sure I've forgotten kind of a couple of them. We've had really great success to do one of two things. First, it has helped us find things, deep vulnerabilities that we would not have otherwise found. It has also helped us the other way, which is it gave us a little bit more confidence that what we're about to publish for broad scale adoption and operation has the properties we hope that it have that we wouldn't have otherwise found even with large scale kind of interop. Something that happened after 114 was really the recognition by the ADs that practice, while prevalent in SEC for big things, is actually not something that occurs all that often outside of the security area. And kind of really the question is, okay, that's not kind of unusual to have different practices, but we have a really kind of nice method to give us a little bit more security kind of assurance. And when would we want to really apply it, fully recognizing that we don't have a lot of that expertise here in the IETF. So how do we bridge perhaps the communities that can do that formal verification? The other motivation for this is that there's an activity in flight in the IRTF. There's an initiative very much how we have a chartering kind of process to create new working groups. There is a proposal in flight in the IRTF to spin up a group kind of more broadly that helps us think how to formally specify IETF protocols, and one subcomponent of that would be specification that would allow us to do this class of formal verification. And not to kind of bury kind of future stuff. Justin Richard is here because he's going to be talking to us about HTTP signatures, which is actually out of the HTTP BIS working group, which is actually the document that started this conversation, because Art came to kind of second, said, wow, during working group last call, there was a question of whether this was formally verified. Well, SEC, I mean, is that a requirement? And we said, well, in fact, it is done quite commonly, but it is not kind of a requirement. And really wanted to get some feedback on the mic. Should we push this more? Should we try to bridge these communities more? Where there would be cases where we want to push more strongly to kind of get this and really solicit, if there are folks in the room, what do you think we can do? Who do you think can kind of help us? We welcome opinions and feedback. I can tell you what sector, we asked the same question at sector, if you're kind of thinking, if you have an opinion, is the recognition that this is helpful, concern that how do we get the help that's needed, and the caution that formal verification is not a magic kind of bullet that will kind of find everything and anything. So I see Philip at the top of the queue. You're up. Philip? We got your video.
Ah, right. Sorry. Okay. Yeah. I'm a big fan of formal methods. I did do formal methods for a doctorate once upon a time. The thing that does worry me a little bit is that when we're using formal methods in the cryptographic algorithm space, we're actually using one set of tools. And that set of tools is not necessarily the set of tools that will be relevant to the protocol work that we do. It's in some ways, it's a more advanced set of tools, but we're looking at can somebody break this, not how does this go wrong? And so it's slightly different. I do have a bunch of tools that I use that are not quite formal methods. I use domain-specific languages to design a lot of my stuff. And it might be that we could find a way of going from a domain-specific language that is optimized for IETF protocol design that would generate the proof of the protocol along with the protocol code and specification. That is probably more practical as an expectation than expecting people to do mathematical proofs of protocols, which, to be honest, I've not done in 25 years. I've not done that since I got my doctorate. I don't think that many other folk do that willingly, unless you've got a grad student.
We have heard kind of similar feedback. I think both themes. One, which is when we say formal methods and formal verification, it covers quite a lot of different kind of practices, and it's you got to be really clear on what properties you're really kind of talking about. And we have equally heard that is not a set of expertise we have in the IETF, and we completely appreciate that. To me, I'll speak for myself. I see this as a bridging exercise about how to reach that community. Thanks, Justin.
Yeah, so I actually wanted to, Justin Richer, I wanted to talk about sort of some of the experience that we've had with this, with OAuth and GNAP and things like that, which, to Phil's point, it was through grad students. There some great master's theses have come out of this work. One of the difficult things with these multi-party, multi-step, and especially stateful protocols and trying to model them is that a lot of times the assumptions of sort of who knows what piece of information is really at any given time is really difficult to model within the tools, because the tools generally tend to have a much more sort of simplified model of A connects to B, therefore A can talk to B, and things like that. The other challenge that we found is we've had grad students come running up to us and saying things. Did you know that bearer tokens can be shared between people and then you can use them? And the entire working group said, yes. And so that type of we know that is a very significant, trade-off in the space, being able to communicate that so that a grad student doesn't spend a month modeling that bearer tokens can be shared between parties, and actually spends time finding sort of the more subtle interconnection problems, which have, I will say, been very, very useful to get that kind of feedback. So I support there being sort of more of an ongoing liaison or onboarding or some type of relationship whereby that institutional knowledge that's in the IETF of we kind of these are our assumptions about the space that the protocol lives in, the kind of stuff that you write down in security considerations, versus the institutional knowledge of this is what the tools can model and how they model those different things, and connecting those things together. Connecting those two sides together is difficult, but I think probably worthwhile in a lot of cases.
Thanks, Justin. So to quickly summarize, you're saying that you've had good experience in two working groups. You're cautioning us that you really do need to help onboard or bootstrap
absolutely
folks, and this is one of the many things we might need to do for bridging.
Yes, absolutely. Thank you.
So just managing strictly by who's in the queue. I think, Joe, you are next. So swap with Mike.
Joe Salloway. And I think Justin kind of said a lot of the things I was going to say, but one of the values of doing some of these things isn't even maybe in the formal analysis, which is important, but just getting to the point of knowing what assumptions you're making and documenting what your security properties you want can be incredibly useful, and something that we don't always do, even in the security area. But outside of the security area, that's one of the things I'd like to see more of in security considerations, right? Is a little bit better analysis of what it is we actually want and what assumptions we're making. And that's going to be the first step in your formal verification anyway, or should be, I think.
Thanks, Joe. Mike
Downsworth. So I have exactly the same comment that Joseph just made, but from the I don't really know how to do this angle. So if you're going to flirt with mandating this in security standards, do we have a prereq is going to have to be a really good how-to document? To what depth do you need to document your assumptions, to what depth you need to document your requirements, what's the formal language for doing so. And for people who've never done formal modeling, that's going to have to be, brain dead simple laid out so that the tools are going to, work well for people who don't really have a background in this.
So if I quickly summarize, I think what you're saying is be very careful with how much formalism you put on top of it. There is an onboarding problem. Training, yeah.
Peter Castleman. I participate in the OAuth working group and a few other places. Similar to Justin's comment, we've used this in a number of places. We're looking at using it for analyzing some of the issues that we see with what we call cross-device protocols. One of the things that I would sort of caution, or a few things to think about, is around education. Also for people who are relying or hearing that there was a formal analysis of this protocol, they don't necessarily understand that there's a set of assumptions, there's a set of models even around the attacker, etc. And if you don't understand that, the proof can very easily be taken out of context or misunderstood, right? So I think some education on that side. The other thing is the limitations of the process itself. So some of the problems that we see, I think it's not very good at modeling human behavior, where we have humans that participate in the protocol. It's not very good, or I haven't seen good instances, and maybe that's a challenge and opportunity for practitioners, is to start thinking about how do we also model human decision-making in this process as well. So maybe there's an opportunity to help advance the field, but be cautious about the limits of the mechanisms. But overall, very supportive of this.
Thank you. And so to reiterate, I think the unique caution you just gave us is to remind folks to not falsely, on the IETF side that are developing the protocols, not to put too much necessarily, to consider what really the proof and the models will bring back to you, and not make assumptions there. So from the other thing that Mike and Justin were talking about.
Bob Moskowitz. My personal experience on this is you need a professor who is interested in your work and in formal proofs. And it happens at a time frame when it's at the beginning of the term, when he can tag a master student or two to do it. And we are now actually having this happening in DRIP that Dr. Gertov has a student actually doing the formal proof because he needs things for his students, of course, and he's been working with us for years. He knows the stuff. So we're getting it done, but it was because of all these circumstances falling together. And back in the spring, he didn't have the students assigned to it. Now here in the fall, at the beginning of the term, he was able to assign a student to it. So it's like the prerequisites of it. You got to have someone who's capable of doing it, and have the resources to do it, and the timing to do it, and maybe you'll get it done.
Yeah, the big takeaway I'm hearing is the reminder that we don't have that expertise as native in the IETF.
Right.
Florence.
Hi. So yeah, broadly in favor of doing something, and I think a lot of really good things have been said about this maybe encouraging us to document our security assumptions when writing properties. Writing protocols. That's a good thing. Not seeing this as a silver bullet. The thing I was going to add is, if we really want this to happen, we really want full verification of standards, then there's probably also something that we could do at the protocol writing stage of how do the IETF write protocols that are kind of conducive to being formally verified. I don't know anything about that, but I'm sure there's a big community that do out there.
Yeah, good point that there's additional work we can do to set the stage here. Next in the queue is Paul.
I think I'm Paul, not Peter. You can be Paul some other time. So with the last couple of comments, it seems, this may be a very small thing, but a formal proofs directorate, similar to the Yang doctors, might be of interest to, and when Bob said, oh, grad students and such, I always cringe because I never was one. But if there are a pool of grad students who are looking for interesting work on formal proofs, even if they have nothing to do with the IETF, if there's a place to put them where we say, we will be offering you things that we're pretty sure is interesting. That is, we've already got something happening in a working group that may be of interest. This may be a crazy idea. Like I say, I'm not in that, but a place where people who want to have I did a formal proof on their resume, that we can say they did a formal proof on this, might be of value.
Thanks. That's a very concrete suggestion about how to integrate with our processes. Peter.
Yeah, just building on what Bob and Paul, this is Peter, not Paul. Just building on what Bob and Paul said, I think what I heard when Bob was talking, I was thinking this is a pipeline. And so in a way, if we can, we need to think about building that process that integrates with where the resources are, the grad students who are doing this work. And that may take a bit of planning, but maybe that's sort of another way to think about it, is that integration mechanism, teeing up these projects, having institutions that we can engage with, so that when fall comes, right, there's that opportunity for the analysis. Maybe that's just one thought.
Yeah, thanks.
All right. I thought I was going to get the last word, but you opened the queue again. Wow. Shit. If you
can come back and wrap it up if you want.
All right. So two things. If you're going to play with academics, you have to understand how the academic world works, and there are things the IETF does not provide that they need. Right. We need to pay for work, in the sense of providing sort of citable references, for instance, stuff that you can use in your academic career. And my understanding from talking to computer science professors back home, that we do not today provide any of those things. Not the ANRP prize and stuff like that. That's kind of, it's going in that direction, but that's IRTF, not IETF, right? If we're bringing this stuff into the operational practice of the IETF, we have to change some stuff. And those are fairly fundamental things, right? The fact that you contributing to a draft that is a temporary thing is something you can cite and get academic brownie points for. It's not something we do today, right? And the directorate's idea, that seems fine, but I think we have to go further. The risk here is that we bring in, the odd academic who happen to be interested in our work, and then we place these requirements on our work and are unable to satisfy them, right? And the other thing that I was going to say is that, beware of the scoping issue in formal verification, as other people have said, right? There's this meme that goes something like, out of scope said no attacker ever. That was going to be the last word, but
fair enough. And I'm going to jump in between. The recognition that credit is really key, and the credit as we think about on the IETF is not commensurate with what's often happens in the academic side. Is my understanding, Joe may kind of correct me here, that's why the Tron workshop was actually created, I think it was with IEEE, because there was a ton of academic interest in TLS-13, but again, they wanted to publish at a citable venue that helps with tenure and kind of credit. And so I believe that was, Joe, if I'm getting it wrong, I mean, kind of back brief it. I'll stop talking. Joe knows more about Tron than I do.
Yeah, so with TLS 1.3, we did hold several workshops in coordination with different conferences, NDSS and a couple other ones. And that helped give a venue for people to be able to present their work in a more academic setting versus a standards meeting.
Okay, so we're going to give Benson the last word. Benson, if you're talking, we don't hear you. You're at the top of the mic. Please turn on your audio and pose your comment or question.
Can you hear me?
We can, indeed, please.
Okay, so maybe increasing the visibility would help. So some of the projects, which could be master's projects or even bachelor's projects, so things used in class, may also be very good, because many of the people who would graduate from even bachelor's programs and master's programs would go straight into the workforce. And it may not necessarily be work that would be considered like publishable or like high credit publishable. So allowing for those kinds of easier opportunities and making those visible would be, I think, a very good thing, especially now that remote participation is much easier.
Agreed. Thanks, Vincent. Okay, we're gonna close this topic. I mean, we very much kind of thank the feedback from the community. This was an open-ended kind of call for feedback. I mean, largely what I heard, and you can kind of correct me if you heard it differently, kind of Paul, is we've had past experience. We heard folks kind of at the mic kind of talk about the goodness. We heard the need for education, bootstrapping, kind of onboarding on kind of both sides. If we're gonna leverage more of that, we may need to do something a little bit different with how we write the specs. We also were cautioned that, you know, be really careful about what would be the expectation from what you get. On the other side, we heard a reminder, a lot of those participants aren't here at the IETF. Also, they may need some help understanding what exactly they would need to formal verify, whether it's the technical thing to catch, or even how mechanically they would reach into the organization, and recognizing that we here at the IETF may not exactly know much about the workflow of those kind of largely academics and researchers that are participating. What I did not hear is anyone going to the mic and say, we should absolutely not do this. And I also didn't hear a very strong statement saying, Roman Paul, this should be table stakes for, you know, for something kind of in particular. I heard something in the middle. I mean, we really kind of appreciate that feedback. Richard, do you have something quick? Oh, you were in the queue. You're out of the queue. Okay, go, Richard. No. Okay. All right. Fair enough. Again, we appreciate that feedback. I think from our perspective, there is a groundswell of activity in the IETF that I think will very much kind of help us. I think all the feedback you heard and kind of your excitement around this, but also your caution, would be great things to give to Colin as IETF chair, who is evaluating whether to spin such a group up. And I'm sure there are a number of proponents pushing that forward. I know Chris Wood is on the forefront of some of that. So I can share some pointers if folks aren't aware in the IETF. Anything else to add? Okay, excellent. All right, that brings us to our last formal topic. Justin, if you want to come on up, I'll get your slides teed up.
I have to wait. So you should get a prompt for me to get the clicker control.
Yeah.
Perfect. Thank you. All right. Hi, everybody. So I'm now going to talk about the draft that caused all those problems. So HTTP message signatures is a draft that is sort of going through the throes of working group last call and in HTTP. I think that's an accurate description. Some chuckles from the ADs if those didn't make it over the mic. But basically, one of the interesting things about this document for this group is that even though this is very much a security-focused thing, it was done in the HTTP space. The goal of this document is to provide detached signatures for HTTP messages, and specifically things that are robust, signatures that are robust against common changes that you see in the HTTP space, you know, headers being reordered and all sorts of stuff like that. I want to be very clear that this is not message encapsulation. This is not OHI. This is not SHTTP. This is not TLS. It is solving a different security problem at a different sort of point of the stack. So this is it tends to be very application focused, where you have a message that you're sending, either a request or a response, and you want to make sure that the party on the other side knows that you are the one that actually sent that specific message. Oh, I'm sorry about that. I hit the wrong button.
No, I got you.
So now I'm going to need to do this button again.
Yeah, I got you. Should be.
Yeah, the next slide and let go of all control buttons are right next to each other, and they're both huge. All right, so the reason that this is in the HTTP group and not in any security working group is it turns out signing a bunch of bits isn't the hard part. Dealing with HTTP is the hard part, right? HTTP is a super weird protocol, especially as it exists in the wild. Like, I did not fully appreciate how weird HTTP is until I got involved with this work a couple of years ago. Like, I knew that it was hard. I had kind of invented various versions of HTTP message signing 3 different times in the past before starting work on this with the HTTP working group. And now going back, I realized that every single one of those has absolutely horrible gaping holes in them, in just different ways that HTTP messages can be legitimately chopped up and moved around without changing any of the semantics of the message, but changing the bytes that actually go across the wire. And as we all know, signatures like dealing with bytes, they don't like dealing with semantics. So what we needed was a mechanism. The goal was to have a mechanism where the signer and the verifier are seeing largely semantically equivalent messages that don't look the same. So maybe it hit an intermediary, or it hit an application layer, or it hit any number of things that could move stuff around. So instead of doing any sort of like strict canonicalization or doing an encapsulation like those familiar with Jose, or you know, tangentially the stuff that they're doing with Ohio, all of that's great stuff. But what we wanted to do instead was to have a common signature base that could be generated from both of these messages. So both from the signer side and from the verifier side. And I'm not going to go into great detail right now unless we have a lot of questions about the mechanics of how this works. But basically what you end up with is you create a signature base string based off of the message that you're signing. And then you write down in sort of a very deterministic format, these are the things that I signed in this order. And then you hand that whole thing to the verifier, who can then look at that and say, I'm going to take this same message and attempt to create the same signature base string. And so anything that was signed, even if it's moved around in the message, I should be able to get the same value out and put it in the base string in the right spot so that all of our crypto primitives actually work. All right. So very quickly what this looks like, we've got an HTTP message here. We've got a few bits that we want to sign. So we've got parts of the what's called the control data I learned. Like there's all this esoteric terminology in HTTP. It's absolutely amazing. If you really, really want to know some weird stuff, buy me a beer and ask me about trailers later. It's bizarre. Anyway, so what we're going to do here is we're going to sign part of the control data, and we're going to sign one of the header fields. And the way that we do that is we say that, oh, and we're signing the method. The font color just didn't show up very well. So we're signing the method. We're signing the target URI, which has a sort of a strict formal definition in HTTP-ish in most cases. Again, HTTP is weird. And then we're signing a particular header. In this very trivial example, it's the content type header. Why you would want to sign only that, I don't know, but we did here. But the important bit is that this last line, the @signature params, this is an ordered list of everything that I just signed, including a set of parameters, in this case, a creation timestamp and a key identifier. And what I do is I actually send that string across the wire. Now we're making use of something called HTTP structured fields, so that even if this gets like white spaces around and stuff like that, this has a formal data model to it in a way that most HTTP messages, the rest of the HTTP message kind of doesn't. So we can rely on being able to get this signature input line in a state that we can actually parse and we can make sense of. And then the signature is just a binary blob, again, using HTTP structured fields, in this case, to send just, I think that's an RSA signature or something like that. And that's pretty much it. You add these two headers, and because they are what are called dictionary type headers, you can add multiple signatures to a single message, which means an intermediary that you know is in the process can take a look at this, validate this signature, add its own headers, sign this signature, and any additional stuff, and pass it along, which means that inside of our data centers, we now have all of these origin servers that are several hops removed from the outside world, can actually validate the message that's coming through. It's a really, really powerful pattern. You can play around with it, see how it works if you go to httpsig.org. I think it's mostly up to date, except for the trailer stuff. Like I said, the trailers are an absolute mess. But you can play around with signing and verification if you want to see how it really works and sort of step through the different parts of the process. But that brings me to why am I here today? We were in working group last call in HTTP. The HTTP nerds have been chipping away at this. I don't think any of them are in the room here because we're meeting opposite of HTTP right now. So yeah, great. The schedule, guys, really. But what we really need at this point is we need more eyes from the security side of things. Both Annabelle and I, the authors on this, like most of our work we do in the security domain. We have an extensive security and privacy consideration section in this document, but we're enough of security professionals to know that we probably missed some things. You know, there's some subtleties here that we may have not picked up on. And we are calling out to the wider SEC community, even beyond sort of the formal sector review. We want more eyes to look at this. We want more people to build and implement this and figure out if there are any gotchas that we need to call out, any, you know, sharp corners that need to be rounded off. You know, it is not an easy space to work in, signing HTTP, but people have been doing it in the wild in sort of dangerous and incomplete ways for well over a decade at this point. Just about every AWS call goes through a whole chain of signed HTTP messages using their own proprietary mechanism. That was one of the inputs to this work in the HTTP working group. So we know that it works within certain domains and boundaries. And we want to make sure that this works in as wide a space as we can. So this is our call out to the wider security area to come take a look at this, play around with it, see how it works, and help us make this the best it can be. That's my last slide.
Mike is at the top of the queue.
Mike Ounsworth. So I recognize this is hard, we need help. When do I get to use it?
So you can use it now, actually. There are a number of implementations in a bunch of different platforms. I've personally written one in Java and a probably not as good one in Python. Like it's out there. You know, Yaron Sheffer has one. I think it's in Go. It's in Go. Okay. And
browsers?
So it is not built into browsers yet. This is something that Annabelle and I have talked about a lot. Ideally, what we would love to see is this part of as part of the Fetch API. So sort of post RFC, that's something that we want to pursue so that a developer doesn't have to think about this, that they call Fetch and hand a key and magic happens. That's what I want, and we've done a little bit in trying to sort of write wrappers around Fetch. A couple of implementations that I've worked on, we've kind of done that kind of thing. On the Java side, my library, I've adapted it so that you can wrap it around a Spring REST template, which is basically the Java Spring version of Fetch. And so you basically make a REST template, hand it a key, and then it handles all of the signature stuff and putting it in the right spot. And then there's a verifier on the HTTP servlet side, again, in Java, that does the reverse of that to make sure that's validated. So yeah, this is out there. I will say one caution though, when you're looking at this, like I mentioned before, people have been doing this kind of in the wild and loosely weird ways for a bunch of years. Well, there's an individual draft called Cabbage Signatures, which a lot of people here are probably familiar with, at least in passing, and especially with the rise of Mastodon over the last couple of weeks for reasons we won't get into here. Mastodon uses a very particular version, a fork of a very particular version of the individual draft of Cabbage Signatures from many years ago. So a lot of people have written implementations of that. That is not the same as what's in the HTTP BIS draft, and we would like to, you know, push that community, a lot of developers in that community to sort of getting up to speed here. So do take a little bit of caution when you pull an HTTP signatures draft because it might mean several different things.
Yeah.
So is this related to SIG v4?
So this is sort of the grandchild of SIG v4. So the Cabbage draft, Cabbage himself wrote SIG v4 at Amazon and then left Amazon and sort of dropped an ID out into the wild, and that was the Cabbage signatures draft. That floated around without a working group for many years. Meanwhile, there were a bunch of other attempts to also do HTTP signatures, and we pulled all of that as input into the HTTP BIS draft.
Including the SIG v4 update?
So
I don't remember what that's called, actually.
I'm not sure what you mean by the SIG v4 update, but Annabelle works for AWS.
Okay.
So she's,
So hopefully she would have gotten.
yeah,
Right.
like I have full confidence that she's got that, you know,
Yeah.
she's got that covered. It is not wire compatible with SIG-V4. There are some severe limitations with SIG-V4 that this overcomes.
All right, interesting. But Amazon's playing, so maybe.
Mm-hmm.
Okay.
I can neither confirm nor deny Amazon's plans for this draft.
Well, nobody can. So.
Joe.
Yeah, I just want to thank you guys for doing this because there are a lot of just Wild West of HTTP signature schemes out there that you end up reviewing, and they're not all great.
Mm-hmm.
So it you know, and it is complicated. And so thank you.
Yeah, absolutely agree. I will say one thing. Like I said, I was not joking when I said that I've reinvented this 3 times. It's a problem that seems to be really easy to do. It's one of those, like, how hard can it be until you sit down to actually do it, and it's really hard.
Philip, you're up next, and Brendan, I think you dropped off. So if you didn't mean to do that, please put yourself back in. Philip.
Yeah, sorry about the trailers thing. I did my best. Basically, what happened was a bunch of folk decided that they didn't want trailers and shipped code that meant that they would never work. Because if you ship a trailer, the browser would think it was the start of the next message. Yeah, I think that this is useful in the HTTP world, but really, I think that we should recognize that web services are not optimal for HTTP is not optimal for web services, and we should build something that is optimal for web services and doesn't start from all the bizarre legacy and so on that HTTP now has. The way that I move signed messages over HTTP is I put a wrapper around it and I ship the payload, ship that as the HTTP payload. And then you get around the need for all this canonicalization or whatever, because your proxies aren't going to mess with it. And that's probably a better way of going about it than trying to get HTTP infrastructure to do things that it should do, but never will because, well, people.
So I will say that replacing HTTP is out of scope of this draft. Talk to the HTTP API group, I guess, for that. And I do want to point out that the authors are very, very familiar with encapsulation-based schemes like Philip was just talking about. We've deployed different versions of that, and there are some really, really big trade-offs into going in that direction as well. Yes, it makes the crypto a little bit easier. It actually makes the messaging portion a lot harder. I do also want to point out that unlike previous versions, this actually works with H2 and H3, just kind of natively. It uses, it's based on, the definitions in the draft are based on the semantic definitions of HTTP. So as close to HTTP gets as having a formal model. This is what everything is defined in, as opposed to previous versions where take these bytes from this string as part of the HTTP 1.1 message.
Yeah, if we could just come back there for a second. If there's some applications where you absolutely need this, and when you've got one proxy that's signing a message and then handing it over to another and handing it over to another, absolutely, you definitely need to have it in the HTTP there, or bad things happen. The place where I'm skeptical is the idea that you want this in the browser. When the browser is producing something that is signed and the receiver is going to be depending upon it being signed, I think that then the encapsulation approach is superior and more likely to appear in the browser.
Brendan.
So to be clear, I haven't read the draft, and I'm just trying to understand exactly what the target is here. Is this essentially providing message authenticity between a pre-established relationship for client to server, server to client? Where does this fit?
So it works for both. server client and client to server.
Okay, and it is.
And key establishment and key negotiation is out of scope of this draft.
Okay, and it's like identity based, not content authenticity.
So content authenticity can be added if you use the HTTP digest draft, which translates sort of the content into a header field, which you can then cover with the signature.
Okay, thank you.
Yep.
I think the queue is dry.
All right, thank you. Yeah, please read the draft, and we want as wide a set of experience as we can on this. Thank you.
So is thank you. So is there anyone who's willing to go on record and say that they will have some extra looks at this and review this? Now is your time for eternal fame. I see. Okay, so then maybe we can do at least another sector review. So I'll get Tero to assign someone randomly, semi-randomly from the room. And that's it. So end of the agenda. So there's open mic. So anyone have any other things they want to talk about related to security?
While you're considering all your questions, I see Kyle in the chat saying he's going to do a review. Thanks so much, Kyle.
Okay, so then see you at online on the various tools that we have, and maybe in Yokohama physically again. Thank you very much.
Thanks, everyone. Or do you want me to tell you?